Hi everyone, welcome back to Technical Mathematics. In this lecture, we are going to have a review of matrices and determinants. We will solve important questions related to matrices and determinants. Also, I will introduce few topics which were not covered in lectures 1 to 5. I encourage you to solve review problems by your own and then check the answers from the solution given in this video. If you haven't watched lectures 1 to 5, I recommend you to watch those videos first and then attempt questions given in this video. Links to those lectures are given in the description box of this video. So let's get started. Question number 1. A matrix has 12 elements. What is the possible number of orders that such a matrix can have? So we are asked to find out possible number of orders of a matrix which has 12 elements. So options are: option A says 12, option B says 8, option C says 6, and option D says 10. So you must be familiar with this problem. We have solved this kind of question in lecture number 1. So you may pause the video and try to solve this by yourself. Okay, now if you have the solution with you, you may check your answer. Here, the right answer is option C, 6. Let's see how to solve this. Here, step number 1 is to find factors of number of elements. Here, number of elements is equal to 12. Now, factors of number 12 are 1, 2, 3, 4, 6 and 12. Now, step number 2 is to count number of factors. Here, you can see that we are having 6 factors. So, therefore, our answer is 6. So, number of possible orders of a matrix will be equal to the number of factors of the number of elements present in the matrix. So, here number of elements present in the matrix is 12. So, we have to find out the number of factors of number 12. Okay, so we will get it as 6 and that is the answer. Now, let's see what are the possible orders in this case. Here, the dimensions of the matrix will be nothing but factors of this number 12. That means we are having 1, 2, 3, 4, 6 and 12 as the factors of 12. So these numbers will be forming the dimensions of the matrix. That means number of rows and number of columns will be any one of these 6. Okay, say suppose if our number of rows is 1, then number of columns must be 12 to get a count of 12 elements. Okay, now if our number of rows is 2, then number of columns must be 6 to get a count of 12 elements. Now, if number of rows is 3, then number of columns must be equal to 4 to get a count of 12. Okay, now the reverse order is also possible. Here we have 1 row and 12 columns. Reverse of that is a matrix with 12 rows and 1 column. That too will have a total number of 12 elements. Similarly, reverse of this one, that will be a matrix with 6 rows and 2 columns. This matrix will also have 12 elements. Now, a matrix with 4 rows and 3 columns will also have 12 elements. So, you can see that the dimensions means the number of rows and number of columns will be nothing but these numbers, that is factors of number 12. So here you can see that we are having a total of 6 possible orders: 1 by 12, 2 by 6, 3 by 4, 12 by 1, 6 by 2 and 4 by 3. So therefore here the right answer is option C, 6. Now let's see question number 2. Question number 2. If A and B are any two non-singular matrices of same order, then A into B whole inverse is equal to. Option A says B inverse into A inverse. Option B says A inverse into B inverse. Option C says A into B. Option D says B into A. So you may pause the video and try to think about the answer. Okay, now if you have the answer with you, you may check it. Here the right answer is option A, B inverse into A inverse. So this question is derived from the properties of inverse of a matrix. It says A into B whole inverse is equal to B inverse into A inverse. So here the right answer is option A. Now let's move on to question number 3. Question number 3. Let A be a square matrix, then which of the following is not a symmetric matrix? So we have 4 configurations here. We have to find out which one is not symmetric. So you may pause the video and try to solve this by yourself. Okay, if you have solved the question, you may check the solution. Here the right answer is option D, A minus A transpose. So let's see how to solve this. So this question is actually derived from the properties of matrices. So if we have a matrix A, then A plus A transpose will be a symmetric one, and A minus A transpose is skew symmetric. So if you know this, you may directly answer the question. A minus A transpose is given here. So this configuration will be a skew symmetric one. So you can directly answer the question within no time. Now if you don't know that, what you can do is you may find out transpose of all these 4 configurations. So A plus A transpose, the whole transpose, will be nothing but A transpose plus A transpose, the whole transpose, that will be equal to A transpose plus A, because A transpose, the whole transpose is A itself. So A transpose plus A can be rewritten as A plus A transpose. So we are getting the same expression what is given here. So when we take transpose of this expression, we are getting this expression itself. So that means this one is a symmetric one. So this is a symmetric configuration. Okay. Similarly, you can see that A into A transpose is symmetric. So when you take transpose of A into A transpose, what we get is A into A transpose itself. Okay. So A into A transpose is a symmetric configuration. Similarly, A transpose into A. When you take transpose of that, we are getting the same thing. We are getting A transpose into A itself. So that means A transpose into A is also a symmetric configuration. So these 3 configurations are symmetric. A into A transpose is symmetric. A transpose into A is also symmetric. Now if you take transpose of this 4th expression, that is A minus A transpose, what we get is minus of A minus A transpose. So that means this expression A minus A transpose is not symmetric. Okay, so therefore here the right answer is option D, A minus A transpose. Okay, now let's move on to question number 4. Question number 4. If A and B are skew symmetric matrices of order n, then option A says A plus B is skew symmetric. Option B says A plus B is symmetric. Option C says A plus B is a diagonal matrix. And option D says A plus B is a zero matrix. Okay, so this question is similar to the previous one. You may pause the video and try to solve this by yourself. Okay, now if you have solved the question, you may check your answer. Here the right answer is option A. A plus B is skew symmetric. Okay, let's see how to solve this. Here in the question, it is given that A and B are skew symmetric matrices. So it means that A transpose will be equal to minus A and B transpose will be equal to minus B. Now to check the validity of the first statement, A plus B is skew symmetric, what we can do is we may take transpose of the expression A plus B and we may try to simplify that to check whether A plus B is skew symmetric or not. So A plus B whole transpose will be equal to A transpose plus B transpose as per properties of transpose of matrices. Now what we have here is A transpose plus B transpose. That may be rewritten as minus A plus minus B as per this relation. Okay, now minus is common in both these two parts. So we may take minus as common. Then we may simplify this one as minus of A plus B. Okay, so we are getting A plus B whole transpose equal to minus of A plus B. This means that the expression A plus B is skew symmetric. So here the first statement given in option A is right. Okay, now coming to the second option, what we have here is A plus B is symmetric. So this statement is wrong because we have just proved that A plus B is skew symmetric. Now option C says A plus B is a diagonal matrix and option D says A plus B is a zero matrix. So these two cases are special cases. We cannot guarantee until we know the values of elements present in A and B. Okay, so therefore these two statements are not 100% correct. Okay, so therefore here the most appropriate answer is given by option A plus B is skew symmetric. Now let's discuss about an identity. If A is equal to cos theta sin theta minus sin theta cos theta, then A raised to n is equal to cos n theta sin n theta minus sin n theta cos n theta. So here the difference is that here we have n theta in place of theta. So when you are calculating nth power of A, we have to change theta value to n theta. So now let's see one question related to this identity. If P is equal to cos theta sin theta minus sin theta cos theta, then P raised to 3 is equal to. You may pause the video and think about the answer. Please make use of the identity what we discussed just now. Okay, so here the right answer is option D, cos 3 theta sin 3 theta minus sin 3 theta cos 3 theta. So here we have to calculate P raised to 3. So you have to replace theta with 3 theta. Okay. Question number 6. If A is equal to cos theta sin theta minus sin theta cos theta, then A inverse is equal to. So you are asked to calculate inverse of the given matrix. So you may pause the video and try to solve this by yourself. Okay. Now, if you have the answer with you, you may check it. Here the right answer is option A, cos theta minus sin theta cos theta. Now, let me familiarize one shortcut method to find out inverse of a 2 by 2 matrix. So this matrix is a 2 by 2 matrix. So we may calculate inverse using the shortcut method given here. So if we have a matrix, a 2 by 2 matrix, A equal to A, B, C, D, then A inverse can be calculated using following steps. Step 1 is similar to the conventional method. We have to calculate determinant of A. So here determinant of A is equal to A into D minus B into C. Okay. Now step 2 is to interchange elements A11 and A22. So those are the elements present in the main diagonal. So interchange those two elements. So D goes in position of A and A comes in position of D. So we have interchanged elements A11 and A22. We will be getting this matrix. Okay, now step 3 is to change sign of A12 and A21. So A12 and A21, those are the elements along the off diagonal. So B and C are the elements along the off diagonal. We have to change sign of those two. So in place of B we will get minus B and in place of C we will get minus C. Now the resulting matrix is this one. Okay, now step 4 is similar to the conventional method. We have to divide with determinant of A. Okay, now let's try to solve question number 6 based on this shortcut method. So this is our question. We have a matrix and we are asked to calculate inverse of that matrix. So the first step is to calculate determinant of A. When you calculate determinant of A, we will get it as cos theta into cos theta minus sin theta into minus sin theta. So cos theta into cos theta minus sin theta into minus sin theta. So we will get it as cos square theta plus sin square theta and its value is equal to 1. So determinant value is equal to 1 in this case. Okay, now coming to step number 2, what we have to do here is we have to interchange elements A11 and A22. That is, we have to interchange elements present in the main diagonal. So in the main diagonal we are having cos theta and cos theta itself. Therefore interchanging these two will not have much result. We will be getting the same matrix itself. Okay, now step 3 is to change sign of A12 and A21, that is changing the sign of off diagonal elements. So here we have plus sine theta, that becomes minus sine theta. Here we have minus sine theta, and that becomes plus sine theta. Okay, now step 4 is to divide with determinant of A. So here determinant of A is equal to 1. Now when you divide this matrix with 1, we will be getting the same matrix. So our final answer is cos theta minus sine theta, cos theta. So this is the inverse of the given matrix A. So here the right answer is option A. Question number 7. If A is equal to 0AB minus A 0C minus B minus C 0, then A is, option A says diagonal matrix, option B says upper triangular matrix, option C says symmetric matrix, and option D says skew symmetric matrix. So you may pause the video and try to answer by yourself. Okay, if you have the answer, you may check it here. The right answer is option D, skew symmetric matrix. So we know that a skew symmetric matrix is the one whose transpose is equal to minus of the actual matrix. So A transpose will be equal to minus A. So if you calculate transpose of this matrix, you will be getting minus of this matrix itself. So this matrix is a skew symmetric matrix. Okay, now let's move on to question number 8. Suppose that A is a 3 by 3 matrix and determinant of A is equal to minus 3. Then determinant of 4A is, option A says 81, option B says minus 12, option C says minus 192, and option D says minus 27. So you may pause the video and try to solve this by yourself. Okay, now if you have the answer with you, you may check the answer. Here the right answer is minus 192. Okay, so we have come across this problem in one of the previous lectures. So here the method to calculate determinant of 4A is like this. So we are given that A is a 3 by 3 matrix. So order n is equal to 3, and determinant of A is given, it's equal to minus 3. So determinant of Ka will be equal to k raised to n into determinant of A. So here k is a scalar and n represents the order of the matrix. So here n value is 3 and determinant value is minus 3, and k value it is 4. Okay, so here determinant of 4A will be equal to 4 raised to 3 into minus 3. So that will be minus 192. Okay. Question number 9. Find inverse of the matrix A equal to 5, 3, 4, 1. So you may pause the video and try to solve this by yourself. Try to make use of the shortcut method what we discussed. Okay. So if you have solved the question, you may check your answer. Here the right answer is option A. Okay. So here as a step number 1, we have to calculate determinant of the given matrix. So when you calculate determinant value, you will get it as 5 into 1 minus 3 into 4. So that is 5 minus 12, and we will get it as minus 7. Okay. Now step number 2 is to interchange elements A11 and A22. So main diagonal elements has to be interchanged. So here main diagonal elements are 5 and 1. So when you interchange their positions, we will get this new matrix. Here we will have 1 and here we will have 5. Okay. Now step number 3 is to change sign of A12 and A21. That is, we have to change sign of off diagonal elements. So here plus 3 becomes minus 3 and this plus 4 will become minus 4. And the last step is to divide with the determinant value. So determinant value is calculated as minus 7. So we have to divide each of these elements with minus 7. So here we will get minus 1 by 7. here minus will be getting cancelled, we will get 3 by 7. Here also minus will be getting cancelled, so we will get 4 by 7, and here we will get 5 by 7 with a minus sign, minus 5 by 7. Okay, so this is the answer that is given by option A. Okay, now let's move on to question number 10. If A is 3 by 4 matrix and B is a matrix such that A transpose into B and B into A transpose are both defined, then B is of type 4 by 3, option B says 3 by 4, option C says 3 by 3, and option D says 4 by 4. So we have to calculate order of matrix B. Okay, you may pause the video and try to solve this by yourself. Okay, now we may check the solution. Okay, so here it is given that A is a 3 by 4 matrix, and also it is given that A transpose B and B into A transpose are both defined. So A transpose into B is defined, means B has number of rows equal to number of columns of A transpose. A transpose into B is possible if and only if number of columns of A transpose is equal to number of rows of matrix B. So when we consider that multiplication criteria, we may write it as B has number of rows equal to number of columns of A transpose. So that means that B has 3 rows, because number of columns of A transpose will be 3, because A is a 3 by 4 matrix, therefore A transpose will have an order of 4 by 3. So number of columns of A transpose will be 3, and therefore B will have 3 rows. Now it is also said that B into A transpose is defined. So B into A transpose, that multiplication is possible if and only if B has number of columns equal to number of rows of A transpose. Okay, so A transpose will have 4 rows and 3 columns. So B has number of columns equal to number of rows of A transpose. That is the conclusion what we are getting. So it means that B will have 4 columns. A dash will have 4 rows, and therefore B will have 4 columns. Thus order of B will be 3 by 4. From this statement we are calculating number of rows of B, and from this statement we are calculating number of columns of B. So order of B will be 3 by 4, and therefore answer is given by option B. Okay, now let's move on to question number 11. Question number 11. Let A be a 3 by 3 matrix. Suppose that the matrix B is obtained from A by the following row operations. Row 1 is interchanged with row 2. Row 3 changes as row 3 plus 5 row 1. If determinant of A is equal to 12, then determinant of B is. So we are having a new matrix B. We are asked to calculate determinant of that matrix. So the matrix B is calculated from matrix A by following these 2 row operations. Okay, so if you know how to solve this, you may try this by yourself. Please pause the video and try this by yourself. Okay, now if you have the answer, you may check it. Here the solution is, answer is given by option B, minus 12. Okay, let's see how to solve this. Here when we perform operation 1, okay, the matrix obtained is taken as A prime, and determinant of that new matrix will be equal to minus of determinant of A. This is because we are doing a row interchange. So the matrix obtained after doing a row interchange will have a determinant value which is equal to minus of the actual determinant value. Okay, now the second operation is a row manipulation, where row 3 is changed as row 3 plus 5 row 1. Okay, so when we do this kind of row manipulation, determinant value will not change, so it will remain same as that of the previous one. So therefore here the final answer will be minus of determinant of A, and that will be minus of 12. So the correct answer is given by option B, minus 12. Okay, now let's move on to question number 12. If a matrix A is symmetric as well as skew symmetric, then option A says A is a diagonal matrix, option B says A is a null matrix, option C says A is a unit matrix, and option D says A is a triangular matrix. Okay, so you may try this by yourself. Please pause the video and think about the answer. Okay, now let's see the solution. So here it is given that A is symmetric. That means A transpose will be equal to A. And it is also given that A is skew symmetric. So it means that A transpose will be equal to minus A. Okay, so these two statements becomes true only in case of a null matrix. Okay, so if you substitute or if you equate the right hand sides of these two expressions, what we get is A equal to minus A. So this criteria is followed only by null matrix. So therefore here the right option is option B, A is a null matrix. Okay, now let's move on to question number 13. Question number 13. If A and B are two matrices such that A plus B and A into B are both defined, then option A says A and B are two matrices not necessarily of same order. Option B says A and B are square matrices of same order. Option C says number of columns of A is equal to the number of rows of B. And option D says A equal to B. Okay, so you may pause the video and try to solve this by yourself. Okay, now if you have the answer with you, you may check it. Here the right answer is option B. A and B are square matrices of same order. Okay, so here let's see options one by one. A and B are two matrices not necessarily of same order. That is what option A says. So if those two matrices are not necessarily of same order, then addition is not possible. Okay, so option A, the statement given by option A is wrong. Now coming to option B, A and B are square matrices of same order. So if they are of same order, then the order of A and B will be n by n. Okay, so multiplication is possible because number of columns of A is equal to number of rows of B, both are equal to n, therefore multiplication is possible. And addition is also possible because they are having the same order. Okay, so option B gives a correct statement. Now coming to option C says number of columns of A is equal to number of rows of B. So this is the condition for multiplication. So this supports multiplication, but it does not support addition. So for example, if we have a matrix like A with order 2 by 3 and another matrix B with order 3 by 2, then multiplication is possible between A and B because A is having 3 columns and B is having 3 rows. So multiplication is possible, but we cannot add A with B because they are having different orders. So this option C gives a statement which supports only multiplication. So C is not the right answer. Now option D says A equal to B. So if A and B are rectangular matrices, then multiplication is not possible. For example, it is not possible to multiply a matrix A with order 2 by 3 with B with order 2 by 3. So addition is possible, but multiplication is not possible. So therefore, here we have only one statement which is 100% correct, that is given by option B. Question number 14. Which one of the following is not true about the matrix? So we have a matrix here and we have 4 statements here. We have to find out which one of these 4 is not true about this matrix. So you may pause the video and think about the answer. Okay, so here if you have the answer with you, you may check it. Here the right answer is option D, a scalar matrix. So let's see the statements one by one. Statement A says that it's a diagonal matrix. That is true because you can see that all non-diagonal elements are zeros. So this statement is correct. Now option B says a lower triangular matrix. That too is correct because for a lower triangular matrix, all elements above the principal diagonal. So here this is the principal diagonal or main diagonal. So all elements above the principal diagonal are zeros for a lower triangular matrix. So that is true in this case. Now option C says an upper triangular matrix. So that too is correct because for an upper triangular matrix, all elements below the main diagonal are zeros. So here this is the main diagonal. Elements below the main diagonal are these three. Those elements are all equal to 0. So statement C is also true. Now coming to statement D, it says that it's a scalar matrix. A scalar matrix is the one which has principal diagonal elements as equal. So here principal diagonal elements are 2, 0 and 5. They are not equal. So therefore this is not a scalar matrix. So the statement which is not true about the given matrix is option D, a scalar matrix. Okay. Now let's study what is a rank of a matrix. The rank of the matrix refers to the number of linearly independent rows or columns in the matrix, or it can be defined as the largest order of non-singular submatrix that can be formed. Note, a matrix is said to be of rank 0 when all of its elements become 0. Okay, to familiarize the calculation of rank of a matrix, let's discuss one problem. Question number 15. Determine the rank of the matrix A given below. So we are given a matrix A which is of order 3 by 3. We are asked to determine the rank of this matrix. Okay, let's see how to calculate the rank. So here A is a 3 by 3 matrix. It implies that a rank of A is less than or equal to 3 because a matrix itself is a submatrix of that matrix. So here submatrix of this matrix will be this matrix itself with an order 3 by 3. So a rank can be 3 or it can be less than 3. So in general we will say that a rank of A will be less than or equal to its order. So here order is 3 by 3 or 3, therefore rank of A will be less than or equal to 3. Now to find out the rank, the first step is to calculate determinant of the given matrix. If determinant of the given matrix is not 0, then rank of A is 3. So here the order is 3, therefore determinant, if it is non-zero, then rank of A is 3 itself. Now if determinant of the given matrix is 0, then rank of A will be less than 3. That is, it will be less than the order of the matrix. So in this case order is 3, therefore if determinant value is 0 for the given matrix, then a rank of A will be less than or equal to 2. Now the step 2 is to find determinant of submatrices with order 2 by 2. And if any of the submatrices have a determinant value which is non-zero, then rank of A will be equal to 2. Else rank will be less than 2. Now let's check this problem. Here we have a matrix which is of order 3 by 3, therefore rank will be less than or equal to 3. Now as a first step we will calculate determinant of A. So here determinant of this matrix will be minus 23. So therefore it's a non-zero value and rank of A will be equal to 3. Okay, so here answer is given by option C and it is 3. Okay, now let's see another problem. Question number 16. Determine the rank of the matrix given below. So again we are given a 3 by 3 matrix and we are asked to calculate the rank. Okay, let's see how to do it. So since A is a 3 by 3 matrix, rank will be less than or equal to 3. As a step 1, we will find determinant of the given matrix A. So when you calculate determinant of A, we will get it as 0. So it means that rank is less than 3. Okay, so we have to proceed with step number 2. We have to find determinant of submatrices of order 2 by 2. Okay, so take a submatrix of order 2 by 2. So here we are taking this submatrix consisting of 2 rows and 2 columns. 2 rows and 2 columns. So 2 0 5 1 is one submatrix of this matrix A with order 2 by 2. So when we consider this submatrix, and if you find out a determinant of this submatrix, we get it as 2, which is a non-zero value. Therefore, a rank of A is equal to 2. Okay, so here the right answer is given by option B, which is 2. Question number 17. If A is equal to determinant of this matrix and B is equal to determinant of this matrix, then B is given by. Okay, we are given 4 statements. We have to find out the right one. Okay, so you may try this by yourself. Please pause the video and try to solve this. Okay, now if you have solved the question, you may check the answer. Here the right answer is given by option B, B equal to minus 4A. Let's see how to solve this. Here B is equal to determinant of minus 2 4 2 6 2 0 minus 2 4 8. Now if you do a row interchange between row 1 and row 3, the determinant value will change in terms of sign. Okay, the magnitude remains the same, but sign will change as minus. So here if we interchange row 1 and row 3, the resulting determinant value will be minus B. Okay, now here in first row we may take 2 as a common factor, and if you take that outside, we may modify this determinant as 2 into determinant of minus 1 2 4 6 2 0 minus 2 4 2. Okay, now here in row 2 also 2 is a common factor, so we may take out that 2 outside. So when we take 2 outside from row 2, we will get 3 1 0 here. Okay, and this 2 will become 4. 2 into 2 4. Okay, and on left hand side we have minus B, on right hand side we have 4 into this determinant. So this is nothing but determinant of this matrix, that is A. So we may replace this determinant as A, and if you take the minus sign on left hand side to the right hand side, we will get a relation between B and A as B equal to minus 4A. Okay, so here the right answer is given by option B, B equal to minus 4A. Question number 18. If A is a skew symmetric matrix of order n and C is a column matrix of order n by 1, then C transpose into A into C is. We are asked to calculate C transpose into A into C. So you may try this by yourself. Please pause the video and try to solve this. Okay, now if you have solved the question, you may check the answer. Here the right answer is given by option C, a zero matrix of order 1. Okay, let's see how to solve this. Here in the question it is given that A is a skew symmetric matrix of order n. We will consider a skew symmetric matrix of order 2. Okay, so we will take that matrix as A equal to 0 minus A 0. So skew symmetric matrix will have principal diagonal elements as zeros, and elements on the off diagonal will be equal in magnitude but opposite in sign. Okay, so we are taking a 2 by 2 skew symmetric matrix. Okay, now C is a column matrix of order n by 1. So here we are taking a matrix of order 2 by 2. Okay, so therefore we will consider a column matrix with an order 2 by 1. Okay, now if C is equal to BC, then C transpose will be nothing but a row matrix with an order 1 by 2 and elements will be BC. Okay, now let's first multiply C transpose with A. So when you do a multiplication between C transpose and A, what we get is A into C as the first element, and second element will be minus AB. Okay, now we will multiply this matrix with C. Okay, so we are multiplying this matrix with C. So what we get is a matrix with order 1 by 1. So here this matrix is of order 1 by 2 and this matrix is a matrix with order 2 by 1. So the resulting matrix will have an order of 1 by 1. Okay, so we are getting a matrix whose elements are, or whose element is ABC plus minus ABC. Okay, so when you simplify this, we will get it as 0. So we are getting a 0 matrix of order 1 by 1. So therefore the right answer is given by option C, a 0 matrix of order 1. Okay, now let's move on to question number 19. The matrix A satisfying the equation. Okay, we have an equation here in terms of matrices. Okay, so we have to find out the matrix A. Okay, so you may pause the video and try to solve this by yourself. Okay, now let's see how to solve this. Okay, so here we will assume that A is equal to a matrix of order 2 by 2. Okay, so we will take the elements as A, B, C, D. Okay, we will multiply this matrix with the actual matrix what we have here, that is 1, 3, 0, 1. Okay, now perform multiplication, we will get a result like this. Okay, now compare the elements on left hand side and right hand side. Okay, compare the elements in respective positions of these two matrices. So when you compare element present in second row and first column, okay, that is C here it is 0. So therefore the value of C is 0. And here in this position we have D, here we have minus 1. Okay, so D will be equal to minus 1. So value of C and D we are getting as 0 and minus 1. Okay, now A plus 3C will be equal to 1. So A plus 3C will be equal to 1 and we know the value of C is 0. So we will get the value of A as 1. Okay, now B plus 3D is also equal to 1. So B plus 3D is equal to 1 and we have calculated the value of D. D is minus 1. So when you substitute that here, we get B plus minus 3 equal to 1 and we will get B value as 4. Okay, so value of A is 1, value of B is 4, value of C is 0 and value of D is minus 1. So we will get all element values corresponding to matrix A and we can form it as 1, 4, 0, minus 1. Okay, so here the right answer is given by option C, 1, 4, 0, minus 1. Okay, now let's move on to question number 20. Question number 20, solution of system of linear equations given below is. So we are given three linear equations in unknowns x, y and z. We have to find out the value of x, y and z. Okay, so you may try to solve this by yourself. Please pause the video and try to solve this. Okay, now if you have solved this, you may check the answer. Here the right answer is given by option D. Okay, so how to solve this? We may make use of Cramer's rule, but Cramer's rule is a little bit time consuming, and especially here the second equation is a little bit complex. We are having a higher number 52 here, so it's better to go for direct substitution in place of Cramer's rule to solve this question. Okay, so now if you substitute values of x, y and z given by option A and B in equation number 1, okay, you may see that it's not 9. So here x is 1, y is 3 and z equal to 4. 1 plus 3 plus 4, we are getting 8 and not 9. So option A is not satisfying equation 1. So this cannot be the answer. Okay, similar is the case with B. B is also not satisfying equation number 1. When we add all these three, we get minus 1 plus 4 plus 4, we are getting 7, not 9. So option B is also not satisfying equation number 1. So this also cannot be the right answer. But option C and option D satisfies equation number 1. Okay, so one among these two can be the answer. Now you consider the second simplest equation, that is equation number 3, 2x plus y minus z equal to 0. When you substitute values of x, y and z given by option C in this equation, what we get is minus 2 plus 5 minus 5. So we get minus 2 as the answer, not 0. Okay, so this also is not the right answer. But if you substitute values of x, y and z given by option D, what we get is 2 plus 3, 5 minus 5, that will be 0. So option D satisfies equation number 3. So therefore option D is the right answer. Okay, so this way we may save little bit time by not going for Cramer's rule. Okay, now with this we are coming to end of lecture 6, and in next lecture we will discuss binomial theorem. We will discuss basics of binomial theorem, and we will solve few problems related to the basics of binomial theorem. Okay, so see you in lecture 7. Goodbye.